Hello students, this is lesson U1A06E. Hopefully by the end of the period you should be able to say I can prove lines parallel. So we're going to approach this lesson in a more algebraic sense first, okay, and then we'll move into a little more abstract, a more abstract approach to proving lines parallel, and what I mean by that is constructing a two-column proof. But in this lesson, we're not going to approach it from that perspective. We are going to prove lines parallel, or show or make lines parallel by manipulating numbers and manipulating algebraic expressions. So let's take a look. These are the, and again, these are the angle relationships that you should be familiar with. And again, just to recap, there are actually a total of 5 different angle relationships. Just to quickly go over that, that's corresponding angles. They're congruent. Alternate interior and exterior angles, they too are congruent. And then you have the other set of angles that are supplementary, and which are consecutive interior angles as well as consecutive exterior angles. These are the 5 types of angles, and they can be actually broken up into those two groupings. So let's take a look at some examples of how we can apply them to prove lines parallel. All right, so what I'm looking at here, okay, question number 1, the instruction here says to find the measure of the indicated angle that makes lines U and V parallel. So we're trying to come up with an angle so that the result is the 2 lines that we see there will be indeed parallel. So looking at this, okay, these 2 angles here, okay, appear to be alternate interior, and alternate interior angles should be the same. And if they're the same, then the 2 lines are parallel. These 2 angles appear to be on the same side, okay, so they're consecutive, and they're in between the 2 angles there, so these are consecutive interior angles. We understand that consecutive interior angles are supplementary, so therefore this angle here must be 135 for lines U and V to be parallel. Looking at this, these 2 angles appear to be alternate exterior angles, and recognizing that alternate exterior angles are indeed congruent, so therefore this must be 52 degrees as well. Question number 4, these are corresponding angles. So having an understanding that corresponding angles are congruent, therefore this angle must be 86. All right, moving on. It says find the value of x that makes the lines U and V parallel. So essentially it's the same kind of question. The only difference is now we're operating more with an algebraic lens here. So I have 70 degrees and then 11x minus 7. These are corresponding angles, and we know that corresponding angles are going to be congruent. So if that's the case, we know that 70 is equal to 11x minus 7. Add 7 to both sides, we get 77 is equal to 11x. Therefore, x must equal to 7. Let's move over to question 6. Question 6 here appears to be, again, we have corresponding angles, so therefore 110 is equal to 19x minus 4, or 114 is equal to 19x, or simply x is equal to 6. If we divide both sides by 19, we end up with 6. Here we have alternate sides, right? And these are exterior angles, so these are alternate exterior angles. So alternate exterior angles are congruent, so therefore 85 will equal to 14x plus 1. So therefore I know that 14x will equal to 84, or simply x is equal to 6. Question number 8, again, these are alternate exterior angles, so I know that 10x is equal to 11x minus 8. If I subtract both sides by 10x and add 8 to both sides, I'll end up with x is equal to 8. Here in this case, the diagram looks a little more confusing, but don't be fooled by this extra line that's drawn over here. It is meant to confuse you. However, please don't fall into that trap. These 2 angles here are actually on either side of the transversal, and they are outside of the 2 parallel lines, so these are alternate exterior angles. So we recognize that alternate exterior angles are congruent. So 7x plus 13 is equal to negative 5 plus 9x. If I subtract over 7x and add 5, I'll end up with 18 is equal to 3x. I'm sorry, not 3, 2x. So therefore x is equal to 9. Moving on to question 10. If I have corresponding angles here, right? Corresponding angles are congruent, so therefore 9x plus 2 is equal to 10x minus 7. So therefore I end up with x is equal to 9. Moving on, question number 11. These are alternate exterior angles, so therefore 25 or 125 is equal to x plus 134. So therefore x is equal to negative 9. Okay? And moving on. So again, that extra pair of line there, it's meant to confuse you, but don't be fooled by that. These are consecutive interior angles. Consecutive interior angles are supplementary. So I know that 19x minus 6 plus 13x minus 6 will equal to 180. Combining like terms on the left-hand side, I will end up with 32x rather. Okay, minus 12 is equal to 180, or 32x is equal to 192. And if I divide both sides by 32, I'll end up with x is equal to 6. Moving on. These are alternate exterior angles, so therefore 7x plus 1 is equal to 8x minus 6. Subtract 7x and add 6 to both sides, I'll end up with x is equal to 7. Moving on to number 14. These are alternate exterior angles, so therefore 80 is equal to 9x minus 10. Add 10 to both sides, I end up with 90 is equal to 9x. Divide both sides by 9. I end up with x is equal to 10. Moving on to 15. These are alternate interior angles, so therefore they are congruent. 80 is equal to x plus 91. Subtract both sides by 91, I will end up with x is equal to negative 11. And moving on. These are alternate exterior angles. So alternate exterior angles are congruent. So therefore, if I subtract over 4x and subtract 5, I'll end up with x is equal to 11. So these are alternate exterior angles, and they're congruent. So if all these x's happen to equal to those values, then lines U and V will be indeed parallel.